Hello all and welcome to SPN. That is some physics news. I'm your host, Liv Myers from Hour 6, and today we are going to be talking about energy. Not the kind of energy that makes your siblings drive you crazy during quarantine, the kind that powers our world. Joining me today will be nuclear energy expert Peter Grace from Hour 3. We are going to be discussing Minnesota's energy plan for 2050 and how nuclear energy fits into that model. Looking at our current energy production in Minnesota, you can notice that about 40% of that is produced by coal, which is very dirty, releases CO2 into the atmosphere, which acts as a warming device for our globe. Tons of negative side effects on our humans' health, but also the environment surrounding us. 15%, give or take, little more as it has been increasing in the past several years, is natural gas. And natural gas has been used more recently because it does produce less air pollution. However, natural gas leaks and how you harvest natural gas is really detrimental to the planet. So in the future, we would like to move away from these non-renewable fossil fuels. Both coal and natural gas are baseload, so they produce the same amount of energy throughout the year, no matter the conditions or needs. Oil is another dirty energy that we are moving away from. So we would like to take a nuclear future. We believe that it can support producing large amounts of energy that will be able to replace the large capacities of oil and natural gas that we have been using. And also with its modern technology, there are ways that are making it a lot safer to dealing with the waste and super consistent. I think we would like to sustain our hydroelectric capabilities and increase wind capabilities, as in the future we are going to need more energy, and with our geography in Minnesota there is tons of opportunity for wind farms.
In addition to this, we intend to include solar in our plan, and this is because we're going to just keep with the amount of solar that's already being used. Solar is used in a lot of residential contexts, and it's a great source for more personable means. However, in Minnesota, wind is a more effective renewable energy source at a broader, more commercial scale. So we will not be expanding it quite the same way that we expand wind and, of course, nuclear energy.
Being the land of 10,000 lakes, but also boasting quite a few major rivers, Minnesota is ideal for hydroelectric energy. Currently, we have 11 plants and a capacity of 120 megawatts, and we would like to keep it exactly the same for 2050. The reason behind this is mainly because of the cons that these plants can have on the environment, especially fish often struggle getting to their migration and spawning grounds. So even with fish ladders and elevators being installed as a way to mitigate that risk, there is still a pretty significant threat that poses to fish. Additionally, water chemistry, water temperature, river flow, recreation can all be things that are strongly affected by these dams. We do feel that they're an important source of energy as they're relatively cheap and they last a super long time. That's right, they're very durable, and obviously Minnesota water, it's a great way to make use of our natural resources that we have here. Both hydroelectric energy and wind energy are fairly cost effective. Looking at the costs of hydroelectric energy, going forward with our 2050 plan of keeping it the same. We will have regular maintenance bills, but the energy itself is very cost effective. It's less than a cent per kilowatt of energy produced. That is about half of the cost of nuclear energy. Wind energy is also pretty cost effective. By adding 100 units, we would add about $275 million to $425 million, which, considering the energy we will get out of that, is relatively cost effective. That will be about 1.3 million to 2.2 million per megawatt hours at the beginning, and obviously it will slowly pay itself back. Thank you. Off to you, Peter.
Thanks a lot, Liv. So I think the best option we have here is definitely to go full nuclear, pretty much in addition to the wind and the hydroelectric that you've already talked about. This will be very effective in meeting our needs in 2050, because not only will we be using nuclear power, which is an effective and high yield energy source that doesn't have a lot of carbon emissions, doesn't really have any carbon emissions for that matter. We're also going to be implementing new stage 4 reactors that actually eliminate any sort of waste and exceptionally increase the efficiency and safety of the reactors. In this implementation, we'll be using what's called a sodium-cooled fast reactor, which will allow us to not have any nuclear waste to dispose of. All the waste will be metabolized in the reaction, and we won't have to worry about that at all. In addition, we can configure it so that the waste that does occur will actually be reusable, recyclable per se, in the reactor again. So we can reuse the fuel and reduce the fuel usage even further. So this will be very cost effective in terms of fuel usage, which can be expensive and can be a limiting factor in reactors. These reactors will be they'll produce a lot of power. So we will have 5 reactors, 3 in addition to the 2 that we already have in the state. They can be in one plant or multiple plants. One plant will probably create more efficiency in terms of cost. And this would be a high price. We would be talking $919 million just for the construction of one reactor. So multiply that by 3, that's about $2.8 billion. A hefty price tag, but it's one that we're going to be willing to pay because it will just help the economy, the energy economy of our state so much. In addition to that, we're going to have to pay $145 million yearly for operation of these plants, and another $5 million in the event of necessary decontamination or decommission of the reactor. Now, this is a big price tag. There's no buts about it, but the possibility for improvement on these plants is insane. These plants currently are just on the drawing board. They've been tested as models, but there are no commercial examples of them because they're not cost effective yet. However, the data is showing that year after year, they're getting more cost effective. And for this reason, if you want to be investing in the future of Minnesota, it'll be very good to have the latest technology, stuff that can circumvent the problem of nuclear waste. And that's why we think this is the best thing for Minnesota. One of the limiting factors of nuclear power plants has been that they can produce nuclear waste, and we don't know what to do with it. How do we store it? How do we keep it out of the hands of bad people? How do we keep people safe from this waste? Well, blowing away all these environmental and humanitarian concerns is a reactor that doesn't produce any waste. And in fact, the only waste that it does produce, if configured to do so, is waste that can be reused and used more efficiently as extra fuel. This is why we need to go nuclear in Minnesota. Overall, our plan is very effective because it uses stalwart and reliable renewable energy sources such as wind and a little bit of solar and hydroelectric to make sure that we have a foundation to move towards futuristic and reliable technologies such as nuclear. With these advancements in nuclear technology, we'll be able to produce plenty of energy that will sustain Minnesota for years to come with no carbon emissions.